here it is x, and here you have fx, and then you have here it is a and here is b. So in terms of the probability density function, so remember now we are talking about continuous probability distribution, so it is probability density function. So fx is equal to 1 over b minus a if x is less than or equal to b, greater than or equal to a, and 0 elsewhere. Okay, so the same thing, when we talk about a probability distribution, we want to know what's the mean, okay, what's the mean, okay, what's the variance. The same thing, what's the mean? So expectation x is equal to, okay, but now remember it is a continuous distribution function, so we have to use integration. So integration from b to a, and here it is x, okay, times fx dx. Okay, any questions so far? And then what is this? Summation, sorry, it should be from a to b, okay. It should be from a to b, from a to b. b minus a and x dx, okay. So because fx is equal to 1 over b minus a, so it is like this, okay. And then it is equal to, okay, what's this? This is going to be x squared 2 b minus a from a to b. If you differentiate this, okay, if you differentiate this, then because this x squared, right, x squared, so 2 times 2 you get 1, okay, and here you have, because of this, okay, dx x to nth power, it is equal to n times x n minus 1's power, right? Okay, so because of this 2 times 2, okay, you get 1. And here, n minus 1, 2 minus 1, you get 1. So you get here. If you differentiate this one, you get this one. So these two are the, so this is what we need to get. Okay. And now, so it's going to be 2, okay, b minus a, b squared minus 2 b minus a squared, okay. And so what you get? You get b squared minus a squared 2 b minus a. So what is that? Here you have b minus a and b plus 8, 2b minus a. So the answer is b plus a over 2. That is the mean. Suppose the continuous uniform distribution is like this. Fx is equal to 1 over b minus a. And here, if you're going to get the mean, okay, that should be equal to b plus a divided by 2. Okay, any questions? Any questions? Okay, let us try to get variance, okay? So what is variance? Variance is equal to, okay, expectation x squared minus mu x squared, right? So then we have to get this part first, okay? So let us try to get this part, okay? Questions? Okay, so here, now we are going to get expectation x squared, right? So you have integration, okay, from a to b, x squared fx dx. And of course this is going to be x squared. Okay? So then, because this is x squared, so what is this? This is going to be x to 3's power, and this is going to be 3. Okay? So if you differentiate this part, you should be able to get this. Okay? Because this is x to 3's power, right? X to 3's power, 3 times 3, what you get? You get 1 here, right? And also 3 minus 1, you get 2, x squared. So it is here. Okay? Any questions? Okay, of course we have to revise what's going on here. So then you have 3b minus a b to 3's power minus 3b minus a to 3's power. So then you have 3b minus a here, b 3's power minus a 3's power. Okay, so what you get? b minus a b squared plus ab plus a squared divided by 3b minus a. Okay? So what does this mean? You have 3 as the denominator and b squared plus ab plus a squared. Any questions so far? Okay, and so this part, we already get it. It is there. A squared plus ab plus b squared, right? Divided by 3. And here, we just get mu x is equal to 2, a plus b divided by 2. But here, it is square, right? So you have to square it. Okay, any questions so far? Can I erase this now? Here, right? Okay, any questions? So let us continue. So move this here. What you get? You get a squared plus ab plus b squared divided by 3 minus a squared plus 2ab plus b squared divided by 4. Okay? And then we have to find this common multiplier. That should be 12, right? And then you have 3a squared plus 3ab. Sorry, it should be 4. You have 4a squared plus 4ab plus 4b squared minus 3a squared minus 6ab minus 3b squared. Okay? Questions? Okay, and then what should be here? It should be 12, and here you have 4a squared minus 3a squared, so you got a squared minus 2ab, because here you have 4, here you have minus 6, and then you have b squared. So then what you get? A minus b squared divided by 12. Okay? So then, if you find out there is a continuous uniform distribution, and then the function is exactly like what I have just shown you, then you know that the mean, okay, if it's a uniform distribution, the mean is a plus b over 2, and the variance is a minus b squared divided by 12. Okay, any questions? So this is continuous uniform distribution. Remember what's the discrete uniform distribution. Okay, suppose px is equal to 1 over n, and you have x1, x2, xn, right? So if that is the case, the mean is equal to m plus 1 divided by 2, and if I get it right, the variance is m plus 1 squared. Anyway, you need to check it, okay? I'm not quite sure about this part, but basically, the calculation is the same thing. Just one for continuous, the other for discrete. Okay, questions? Any question? Then we're going to continue to normal distribution, okay? Normal distribution. Okay, normal distribution, it is kind of interesting because when someone developed this distribution, it is so striking, okay, it's so striking that this kind of distribution can represent a lot of social or natural phenomena. So for example, in terms of the weather, as we know, generally the weather is just fine. But sometimes, okay, there will be storms, okay, sometimes thunderstorms, sometimes it rains quite a bit. But generally, the weather is just like this. So that's quite normal. So for those days with a lot of wind, for those days with little wind, or, a lot of rain, very little rain, there are very few. So generally we are in a normal situation. And talking about people, there are a lot of tall people, right? A lot of people quite tall, a lot of people quite short. But, generally people get into the middle. So, for example, just like us, here we don't have, very, you can say strange, okay? Or we say abnormal. So generally, if you're going to buy clothes, okay, if you're going to buy clothes, went to a department store, generally you can find your size very easily. Okay, basically for all the companies, okay, for all the avatar company, making clothes, they check the distribution of height and weight. And suppose you are the kind of people, really, really thick, okay, then you have to get your clothes somewhere else. And also in terms of score, okay, so I have been teaching statistics, economics for quite a while. Very few people did well. Very few people did badly, okay. Generally people are in the range from 60 to about 80, okay. So for those people score above 90, very few. For those people score below 50, 60, is quite few. So, it is kind of interesting why this happened. But, this is a phenomenon, characteristic of our society and also for the nature. And so, because of this, it is very important to study normal distribution. And now let me put down the function of normal distribution for you. So this is the probability density function of normal distribution. So fx is equal to sigma x square root 2 pi times e, that's the natural log, okay, the base of the natural log. 1/2, negative 1/2, x minus mu x sigma x squared. Okay? So this is the probability density function for normal distribution. And for this kind of distribution, it is denoted as normal. N means normal, and mu x and sigma x squared. And because, there are a lot of variation in terms of the mu, okay, that's the mean, and also for the variance. So, for example, if you look at this, okay, this is a normal distribution, and also this is a normal distribution. The difference is variance, okay. So for these two normal distributions, okay, the mean is the same. But what about the variance? So this one is a little bit taller, and this one is a little bit fatter. But these two are the same. I mean, in terms of distribution, they are all normal distribution. And also, if you look at this, so this is normal distribution. This is also normal distribution. And if you look at it, you can see basically the variance is the same for these two normal distributions. But what about mean? The mean is here, and here the mean is here. Okay? So because normal distribution has certain kind of characteristics, if you look at it, actually they share the same kind of properties. Just because it has a different mean, different variance, doesn't mean that it is not normal. And also we have a way to standardize it. So generally when we look at normal distribution, we will transform this kind of normal distribution into a standardized normal distribution. And standardized normal distribution is called Z. And what is the variance for standardized normal distribution? It is equal to 1. And what about the mean? It is equal to 0. And how are you going to standardize it? The way to standardize it is Z equal to X minus mu X divided by sigma X. And if you remember, we actually proved this before, right? We proved that the mean of Z is actually equal to 0. And the variance is indeed equal to 1. Okay, if you check your note, you should be able to get it. Of course, there are some other kinds of properties for normal distribution, and we're going to continue to explain what's the properties there. Okay, so this is a normal distribution. We take a break. Properties of normal distribution. So properties of normal distribution. So basically normal distribution looks like this. It is called bell shape. Bell shape. So it looks like a bell, okay? So Christmas is going to come, right? Jingle bell, that kind of bell. So bell shape. And so if you look at this, the highest point is here. So the maximum value is here. Fx mu x. So when x, so the first point, when x is equal to mu x, fx has a maximum value, okay, has a maximum value. And here, so if you look at this, suppose the distance is sigma x, and the distance is sigma x. Of course, this is plus, mu x plus sigma x, and here is mu x minus sigma x. So the second point is when x is equal to mu x plus minus sigma x, fx has inflection points. So there are two inflection points. So what is inflection point? Mr. Zheng, what's inflection point? What is inflection point? So when a function has a maximum or minimum value, the first derivative, okay, the first derivative is equal to 0. When they have inflection point, the second derivative, okay, is equal to 0. So basically, here you have f prime x equal to 0, and here you have f double prime x is equal to 0. Okay, and the third point. The third point is this is symmetric. Okay, this is symmetric. Symmetric is like a mirror. Okay, so if you look into a mirror, what do you see? You see yourself. The same thing. So this is a symmetric. Okay, symmetric. That means if you fold, okay, use mu x as the center. If you fold it together, you get exactly the same thing. Okay, you get exactly the same thing. And so because of this, if it is symmetric with this mu x as the center, can anyone tell me what is the value here? Okay, what is the value, the probability on this side? Okay, Mr. Wu, what's the value on this side? How much it should be here, probability? Yeah, 0.5, right? Here, the same thing, because it is symmetric. And of course, there are some other kinds of property, okay? So, if you look further, okay, further right or further left, the probability, I mean the height, okay, the height of this function is getting smaller and smaller. So this is what we call asymptotic. This is a asymptotic line, okay? It is getting closer and closer to infinity. And here is getting closer and closer to negative infinity. So the domain for the normal distribution, it is from negative infinity to positive infinity. Okay. The most important thing is they are symmetric. Okay. This symmetric property has a lot of applications. Okay. So when we gonna look at the probability, okay, of any kind of variable, okay, between x1, x2, whatever, we use this kind of symmetric properties. So can we get distribute the sheet to people? Give me some. Okay. So later on, you have to return the this distribution table to Mr. Zhuang. Okay. When we get to examination, we need to use this. Okay. Don't put any marks. Okay. Don't put any marks. Okay. Don't put any marks. Okay. Because this kind of properties, also actually we can calculate the property. I mean the probability for all the value we would like to have, and it is because of this reason we have a table. Okay. So whenever we talk about normal distribution, we talk about standard normal. In any case, if it is not a standard normal distribution, you need to transform it into a standard normal distribution first. Okay, let me give you some values that we use quite often here. Okay, so for the first thing, now we are talking about standard normal. Okay, standard normal. So we have P. Okay, Z is the notation for standard normal distribution. Greater than or equal to -1, less than or equal to 1. Okay, the probability is equal to 0.683. Okay, and for probability -1.64, less than or equal to Z, less than or equal to 1.64, what you get? You get 0.9, okay? And then Z, greater than or equal to -2, less than or equal to 2, what you get? You get 0.954. And Z, less than or equal to -2.58. 2.58 is equal to 0.99. And Z greater than or equal to 3, -3, it is equal to 0.997. Okay? So basically this is the table. Okay? And now we are going to check, so let us then to check this table first. Okay? Okay. So if you look at the table here, right, there is a chart. So what does the table tells you? The table tells you, okay, P, Z greater than or equal to 0, less than or equal to Z. Okay? So here is what the table gives you. Okay, here is what the table gives you. And so where is it? It is from here, right, Z. 0 to little z. Okay? So here is what you can see in the table. Okay, so what does that mean? So if you look at, if you want to find out P, okay, Z greater than or equal to 0, less than or equal to 1.24, how to get that? Okay, so first, this is the first column, right? First column, Z. You have 0.0, 0.1, up to 3.0, right? And here, on the raw side, okay, the horizontal side, you have 0.00, 0.01, up to 0.09, okay? So now you are going to find what is the probability between 0 and 1.24. How are you going to get that? So first you look at the first column, 1.2. Okay, can you see 1.2 there? So 1.2, okay, and then the second column, 0.00, right? So that means 0.3849. Can anyone see that? 0.3849. That is the probability for Z between 0 and 1.20. Okay? But here, at this point, we are going to find out 1.24, right? So between 0 and 1.24. So you have to look at 0.04, right? If you look at 0.04, and then you have 1.2 there, okay, 1.2, look at it horizontally, and use the 0.04 vertically, and find out the intersection there, you get the probability for Z between 0 and 1.24 is equal to 0.3925. Okay? Can anyone find it? If you cannot find it, raise your hand. Okay, if you look at this, do you have a table? You do, right? It should be the same thing. So you look at, let us try something else. Okay, so let us try to find between 0 and 2.4. Okay, and 0 and 2.4. Okay, the lady there in black shirt. So can you tell me what's the probability for P, okay, between 0 and 2.4? Between 0 and 2.4. First you have to look at 2.0, right? Okay, you have to look at 2.0. And then you have to look at, it is equal to 0.4918. Okay, so let us try 0.44. Okay, if you are going to find out between 0 and 2.44. 0.4927, right? Okay, so it is not that difficult. Okay, now let's try something else. So generally you have to learn to draw a diagram. Okay, you have to learn to draw a diagram so that you know which area you are talking about. Okay, so now let us try to do this. Okay. Now you are required to find Z less than 2.44. Okay, so can anyone tell me what is the area below 0.44? So that gentleman in black t-shirt. Z less than 2.44. So you know this, right? When Z is between 0 and 2.44, that is equal to 0.04927, right? Okay, and what about this? Z less than 2.44. How much is that? So the first thing you have to learn is, okay, Z is equal to 2.44. It is here, right? But you are going to find out what's the area. Z less than 2.44. So it is here and here, right? So how much should that be? 0.5 Are you sure? Are you sure? This area alone is how much? This area alone. If you just look at this area, how much should that be? It should be equal to 0.5, right? This area plus this area. So it should be equal to 0.9927, right? Because Z less than 2.44, it is this area to the left. So it is this whole thing plus this area. And how much is this area? It is equal to 0.5, right? So it is this area plus this area. Okay? Do you get it? Okay. Now let us try another one. So we get here PZ less than negative 1.75. Okay? Can anyone tell me what is the area for Z less than negative 1.75? So now you must have a question, right? For all the table here, is there any negative number? There's nothing, right? There's no negative number. So how to get negative number? But remember, we talk about this. What's the property of normal distribution? It is symmetric, right? What means symmetric? So let us look at this. So first, can anyone tell me when for the probability of Z between 0 and 1, what's the probability? Between 0 and 1. So the next one. Yeah, is in. So what's the probability for Z between 0 and 1? You have to look at this table. How much is that? Okay, 0.3413, right? Okay, so then, what's the probability for Z between 0 and negative 1? Is U. 0 point? The same, okay. 0.3413. Because of what? Because it is symmetric, right? So this area must be equal to this area because it is symmetric. If the distance from here to here it is equal to 1, then from here to here it is also equal to 1, the distance, okay? And so the area must be the same because it is symmetric, okay? Okay, now, so gentlemen, is you again. So can you tell me what's the probability for Z less than negative 1.75? Less than negative 1.75, sorry.
1.045.
1 minus 0.5 minus 4599. So then for the probability between 0 and 1.75 must be equal to this one, right? So let us check. 1.75, right? So indeed it is 0.4599, but you don't need to use this because here, right? Negative 1.75. So you are looking at this area, right? So what's the whole area? The whole area is equal to 0.5. So actually, of course, 1 minus 0.5 is equal to 0.5, right? But you actually don't need this process here. So you just put 0.5. It is this area, 0.5, right? And subtract here. Okay, subtract this one. Then it is this one, right? These two areas put together is equal to 0.5. And so from here to here, because what you get on the table is for the probability between 0 and 1.75, that is this area, right? Okay, 1.75. Because this area is equal to 0.4599. So for this area, subtract this area, then what you get? You get the area that is less than negative 1.75. Okay? Any questions? Okay, let's try one more. What about this? We are going to find out P, okay, negative 1.64 less than or equal to Z greater than less than or equal to 3. So what's the probability here? So, Mr. Zen, what's the area here? Can you get it? 0.4987. And then plus 0.4495. Okay, so then let us check this diagram. Okay, so you have to be able to draw the diagram to get the correct answer. So here you have, okay, 3 is here, right? And then here you have 1.64, but it is negative. So you are looking at these two areas. This area, right? And plus this area, right? So then, because the table tells you from 0 to 3, okay? Probability from 0 to 3 is 0.4987. And from 0 to 1.64, it is 0.4495. Even it is negative, right? But this is negative. So here it is symmetric, okay? It is symmetric, so then you can get this, okay? Okay. So basically, it looks good. It sounds like you are able to look at the table and find out the corresponding probability. Now let's get to some other questions. So first you have to learn. You have to know. Usually the question won't tell you in terms of the standard normal. So you have to transform the distribution into standard normal yourself. Okay, so let us look at the question here. Okay, so let us say this is a normal distribution. The mean, okay, is equal to 20 and the variance is equal to 4. And now, okay, the first question, you are required to find out Px greater than or equal to 24. Okay? And the second question is, you are required to find out x greater than or equal to 16, less than or equal to 24. Okay? And the third one, suppose there are 1,000 samples. How many are between 16 and 24? Okay, so let us deal with the first question first. Okay, you are required to find out what's the probability for x greater than or equal to 24. So when you are dealing with this kind of question, because it is a, not standard normal, so you have to transform that into standard normal. So Px greater than or equal to 24, okay, here you have to transform to z. So what is z? Z, okay, z is equal to x minus mu x sigma x, okay? So if you look at this is already z, right? Okay, this is already z. In terms of x, you are looking at 24. In terms of z, what are you looking at? You are looking at this, okay? X minus mu x, okay? So z is equal to x. How much is mu x? How much is mu x? How much is mu x? 20, right? How much is sigma x? 4, okay? So basically, you already turn this x into z, right? Okay, you turn this into z. So this one is no longer 24 because you are looking at z, right? So how much it should be the z? You plug 24 here, okay? Because z is equal to x minus mu x divided by sigma x. And here you already transform this x variable into z variable. So necessarily you have to turn 24. This is the value for x. So when it is 24 for x, how much should it be for z? Okay? So what should be here? You have to get 24 here, right? Okay. So then you say z is greater than or equal to, because now you cannot use 24. Because 24 is for x. You have to find out the 24, the corresponding z for this 24. So this 24 should be here, okay? 24 minus 20 divided by 2. Okay, so what you are looking at is probability of z greater than or equal to 4 divided by 2. So that is equal to probability z greater than or equal to 2. Okay? So can anyone tell me what's the probability here? So the gentleman next to Mr. Zen, what's the probability? Look at the table. (0.5 minus 0.477? How much is that? 772. Okay. So the probability is actually equal to 0.0228, right? So this is the step you have to follow, okay, all the procedures. First you look at x, right? But actually you are looking for z, okay? You are looking for z, so x is greater than or equal to 24, but for z, how much should that be? You have to use this formula here. So x, plug it here, okay, and of course the question already tell you what's the mu x and what's the variance. Questions? This is, remember the notation we have is x is equal to normal distribution, right? Mu x sigma x squared, right? So here it is sigma x squared. So sigma x is equal to 2. Okay? So this is the usual, usually we put it this way. Okay? But sometimes we will tell you standard deviation instead of variance. But usually when you look at this, when you look at this kind of notation, what does that mean? That means this is mu x, this is variance. Okay, usually it's like this. Okay, questions? Okay, let's get to the second question. Okay, the same thing here. Can I erase it? Okay. Okay, for the second one, we are looking at for probability x between 16 and 24, right? Okay, and so what you have? The same thing. You have to, this is x, it is not z, right? This is x, it is not z. So you have to get this into z. Okay? The same thing. 16 minus mu x, it is 20, divided by sigma x, it is equal to 2. Okay? Greater than or equal to, now it is z, right? Okay. And then the same thing, 24 minus 20 divided by 2. So what you get? P is equal to negative 2, less than or equal to z, less than or equal to 2. Okay? So then it should be 0.4772. Okay? Sorry. Plus 0.4772. Okay? Any questions? So basically, it is very simple. You just turn the x distribution into z distribution and then find out the corresponding value. That's it. Okay. Okay, let's get to the third one. Okay. So suppose there are 1,000 samples. Okay, 1,000 samples. How many are between 16 and 24? So n. Okay, n is equal to 1,000, right? And if you look at this, it is equal to 0.9544, right? So what is this? This is actually relative frequency, right? This is relative frequency. So this is relative frequency, and you are going to find out the frequency. So you've got to know that relative frequency is equal to frequency divided by n, right? So relative frequency is equal to frequency divided by n. And so from here, you already know the probability. And this probability is actually relative frequency. So f is equal to n times Rf. So how many samples between 16 and 24? 954, right? 954. So it is equal to f is equal to 1,000 times 0.9544. Basically, that's equal to, 954. Okay, 954. Question? Okay, let us get to another question here. So let us say we are looking at a different table. Let me try. Okay, let us look at this. Okay, let's look at a different example here. So the defective ray Okay, so basically this is a binomial distribution. Okay, this is a binomial distribution. And I already told you, when n, the sample size is very big. When the sample size is very big, you can use standard normal distribution to find out the value of a binomial distribution. So let's take a break.